If A and B are two events and the probability of A is 0.6, the probability of B is 0.3, and the probability of A union B is 0.8, we want to find the following. Well, part A and B, we can find that using our formula. The probability of A union B is the probability of A plus the probability of B, take away the probability of A intersection B. And we can rearrange this quite simply to give us A intersection B is the probability of A add the probability of B, take away the probability of A union B. So that's going to be 0.6 add 0.3, take away 0.8, which gives us 0.1. And from that information, we can draw a Venn diagram. So here's our bounding rectangle, and then we'll have event A here and event B here. So this is A, this is B. We've just worked out that this is 0.1. The probability of A is 0.6, and if 0.1 is in the middle, that leaves 0.5 in this bit, so that we have 0.6 in total in A. The probability of B is 0.3, so this bit here must be 0.2. And altogether, we can see that that is 0.8, leaving 0.2 to go in the outside. So now in part B, we want the probability of not A intersection B. So let's see if we can identify what that looks like. So if we have a diagram here with A and B like so, so this is A, this is B, and then we'll have not A, well that's going to be everything outside of A. So it's going to look something like that. And then what we want to do is shade B. So what we want is a different colour. So if we shade B like so, and then since we're looking at an intersection, what we do is take just that part which is shaded twice, and we can see that that's this area just here, so therefore this one is 0.2. So now let's go for part C. So if we just get rid of the shading here, we could probably make a copy of this diagram, and this one is A intersection not B. So I'm just going to copy this diagram, and let's just drag that over here. So we're after the probability of A intersection not B. So applying the same sort of idea, I'll start by shading A, and then let's change the colour, and we'll shade not B. So that's going to be around the outside of B. So it's going to be all of this. And then since it's an intersection, we want the double shaded bit, which is this bit in here. So that one is going to be 0.5. Now with D, probability of A dashed intersection B dashed. So let's get another diagram, another copy of our diagram, bring it in. So A dashed is everything outside of A, So that's going to be sort of around here. And then if we get a different color, and we'll shade everything outside of B. So that's going to be like this. And then we want the double shaded because it's an intersection. And we can see the bit that was shaded twice is the stuff all the way around the outside. So that's going to be 0.2. So moving on to E. This one is A union B dashed. Well, we can use this diagram over here. We shaded A and we shaded B dashed in this diagram. When it's a union, we take everything that's shaded, whether it's shaded once, like this bit, or twice, like this bit. So it's everything except this part in here. So that part there is 0.2, so this one has to be 0.8. And then F is A dashed union B. So this diagram here would have been the one to use, but I unshaded it. Let's just do that again. So A dashed is everything around the outside of A, like so. And then B is everything inside of B, so like this. And again, this time we're going to take everything that's shaded, whether it's once or twice, because it's a union. So that's everything except this bit. That bit's 0.5, so this must be 0.5.